This is a schematic of a simplified electron microscope. At the top, electrons flow through a wire attached to a finely polished tip. Electrons emerge from this tip and are directed down the column by a Wienold cylinder or extractor. The electrons are then accelerated to nearly the speed of light by the accelerator stack. While in fact electrons travel through the column one by one, here we show their combined paths as a continuous beam. The first element the beam passes through is a deflector. Deflectors have the ability to alter the beam path twice, allowing the beam to be centered within the lens below and aligned along its axis. The next element is a lens. Lenses focus incoming electrons towards a point along their axis below. Because lenses are never perfect, stigmators are used to add asymmetric focusing power as necessary to circularize the beam. Apertures block electrons traveling far from the axis. Together, a deflector, lens, stigmator, and aperture constitute a lens system. The first lens system is called the condenser lens system. The next lens system is the objective lens system, where the sample rests, followed by the projector lens system. Each system has the same basic elements, but some elements have been given special names to reflect their function. The first deflectors are called, for instance, the gun deflectors, since they position the electrons emerging from the gun. The next set of deflectors are called the beam deflectors, since they position the beam that hits the sample. The third set of deflectors are called the image deflectors, since they reposition the image on the next set of lenses. The other lenses, stigmators, and apertures are simply named after their lens system, except the last aperture, which is called the selected area aperture. In real microscopes, the condenser lens system is often more complicated, containing two lenses and two apertures, called the first and second condenser lenses and the first and second condenser apertures. Projector lens systems also contain multiple lenses, with the first lenses called intermediate and the last lens called the projector lens. Samples are inserted into the middle of the objective lens. There are many ways that electrons can be scattered by the sample. When the sample is thin and made of light atoms, the majority of the imaging electrons pass through unscattered. Others are absorbed by the sample, contributing to amplitude contrast. Still others are deflected by the sample, and if they are deflected to high enough angles that they hit the objective aperture below, they also contribute to amplitude contrast. To understand phase contrast, we must think of the electrons as waves. As electron waves pass through the sample, fields within the atoms in the sample cause phase delays. The perturbed waves are refocused by the objective lens and interfere with the unscattered beam to produce phase contrast. Images are formed by the combination of all these processes. The images are magnified by the projector lens system and built up one electron at a time on the detector.